I'm sure most of you must have listened to or watched our videos on the art of problem solving, which explains how to tackle different types of questions, right? There are several webinar videos that were conducted by us in the past on the art of problem solving. Those are mostly theoretical stuff. But students have come back to us saying, yes, ma'am, we understood how to do it. But when it actually comes to doing it, we are not able to apply it properly. Now, this reminds me of the famous quote by Confucius. I hope you all know this. I hear, I forget, I see, and I remember, I do, and I understand. So what is the crux here? You need to do, you need to practice. So unless you do, it will definitely not get registered in your mind. Practice is the key word in mathematics. Unless you practice different types of problems, you will not be able to get a grip of the techniques that we share. Now, let's get started. Select exactly one answer choice. If A is greater than B is greater than C is greater than D, and if A is equal to 2, then which of the following must be negative? The options are AB, AC, BD, BC. Option E is none of these. The answer is option E, that is none of these. A is greater than B, greater than C, greater than D is given to you. A is equal to 2 is given to you. So the best way to do it is here is. Now, can one of you who have got the right answer tell me what method you adopted to solve this problem? Can you just type it in the chat box there? Wonderful. Ratish says ZoneF. Wonderful. He's one of our enrolled students. So he's very much familiar with that mnemonic ZoneF. Yes, Ratish, we'll be coming back to that. Right. ZoneF. Okay. Before we move on to ZoneF, let me first attempt this, solve this, explain this problem, and then move on to that ZoneF, the art of plugging in numbers. Okay. Plugging in values. So you just given that A is greater than B, greater than C, greater than D, which means that B, C, D can be any real number, right? It can be positive, it can be negative, it can be 0, anything. A is equal to 2 is fixed. As long as A is greater than B, greater than C, greater than D, you can have any choice for B, C, and D. A is equal to 2, then D must be negative. Who told you that, Amit? It is nowhere mentioned that B, that's a very, very common mistake that students do. It doesn't mean that D has to be negative. Doesn't say that B, C, D are all integers, right? I could take my B as 0.1, I'm sorry, 0.1, C as 0.01, and D as 0.001 also, right? It doesn't say that B, C, D are integers. That's a wrong notion. But it so happens that for this problem, it does work out. But please do not take it like that. So that is where Ratish has mentioned something about ZoneF. We'll come back to that. So plugging in values, as you can see, I've taken B is equal to 1. BCD can be negative and positive. Wonderful, Kivani. That's what we wanted. BCD can be both negative and positive. Look at the choices of BCD. You can plug in any number that you want, but make sure that you plug in properly both negative and positive values. The first case, it might sound that option C is correct, where BD is less than 0. But in the second case, we have got BD should be greater than 0. So when you have this clause must be, it has to work out for all numbers. That is the watchword here. The watchword here is must be, which means any number you plug in for BCD, the option should be right. Correct? So here, for different values of BCD, you get different possibilities. That is different answer choices. That is, for some cases, you get BD less than 0. For some case, you get BD greater than 0. So the answer here is option E, that is none of these. The question was, let me go back to the question, which of these must be negative? None of these must be negative, right? AB can be negative, positive, or 0. AC can be negative, positive, or 0. Again, BD can be negative, positive, or 0. BC can be negative, positive, or 0. Again, it depends on what numbers you're plugging in. Since the question says must be is a very important watchword here. The question says must be, so which means for all values, that option has to be true. Right, wonderful. Most of you have, all of you have actually got it right. Amit, please be careful. D need not be negative here because we are looking at real numbers. It is nowhere mentioned that these have to be integers, right? Okay, fine. Ratish mentioned something about a mnemonic called as ZoneF. Let's look at what is ZoneF. ZoneF is a structured way of plugging in numbers. Now, students who have enrolled on our platform, they would have seen it all, most of our videos where this mnemonics highlighted. What is ZoneF? When you plug in numbers, there is quite a possibility that you miss out on some numbers. For example, Amit has told D must be negative. Need not be. D can be, need not be an integer always, right? It can be a real number. So zone F, Z stands for 0. Try plugging in 0. O stands for 1. Try plugging in 1. N stands for negative number. You should be very careful because negative numbers reverses the inequality. Okay, this is a very, very important point. When you multiply two sides of an inequality by a negative number, the inequality gets reversed. E stands for extreme. Try very large numbers, say from close to 10,000. The other value that you're going to substitute can be 1 by 10,000. Funny things happen at extremes. F stands for fractions. I just told you, when there's no information about the numbers given there, you can always plug in fractions also. It could be a decimal or it could be a fraction as long as it's a real number. According to ETS norm, we deal with real numbers only. Okay, right. Now, shall we move on to the next question? Second question. Compare the quantities A greater than B greater than C greater than D, and if A is equal to 2, quantity A is AB, quantity B is BC. It's a quantitative comparison questions, and most of you, all of you must be GRE aspirants, right? So you will know that quantitative comparison questions, the 4 options, these are just MCQs with 4 options fixed. Option A will be quantity A is greater. Option B is quantity B is greater. Option C is both the quantities are equal. Option D is the relationship cannot be determined. Okay. Some of you say it's A. Some of you say it's AB, A and B. Oh, you mean quantity A is greater? Pooja says quantity A is greater. Abhilash says quantity A is greater. Okay. Ratish says cannot be determined. Sanket says quantity A is greater. Prakash says quantity cannot be determined. Okay. So Ratish is right, Prakash is right, cannot be determined. So why is it so? So what is the mistake that you people have committed? Let's look at it. Okay. Now, as I told you, we just saw something called a zone F. We found out that it's given that A is greater than C. Just now I told you that B need not be positive, right? So if A is greater than C, when you multiply it by B, if B is negative, then AB is less than BC, that is quantity A is less than quantity B. But if I take B to be positive, then what happens here? When B is negative, AB is less than BC. When B is positive, AB is greater than BC. Can you see that? Just to recall the plugging in numbers, I've just given A is equal to, that's fixed. If B is -2 and C is -3, I've taken B to be negative here and C to be negative. In that case, BC becomes positive. So AB is less than BC. Yeah, but B and C can be anything, negative or positive, perfectly fine. You're just comparing both the quantities AB and BC, right? It can be anything. That's why the answer is relationship cannot be determined. It can be any value. So if you plug in negative value, get AB is less than BC. If you plug in a positive value, AB is greater than BC. You have inconclusive statements for different values of B, right? In that case, when you cannot conclude for sure that AB is greater than BC or AB is less than BC, you go for option D. You get my point? So when do you go for relationship cannot be determined? When it doesn't work for all the values. When one relationship cannot work for all the values, then we go for option D. Most of you plugged in option A because you had multiplied by B on either side, assuming B to be positive, which is wrong. Can you see that? When B is negative, the inequality gets reversed here. Do you all accept that? Did you all understand? Any doubts? Kivani, anything? Any doubts? Did you understand this? B and C can be anything positive or negative. Yes, true. That is the reason we have option D. If it's negative, we get quantity A is less than quantity B. If it's positive, we get quantity A is greater than quantity B. So for different values, we get different answers. So the final answer would be just option D. Yes, everybody else who had got option A, did you get it clear? Wonderful. So what is the bottom line here? You should be familiar with the concept of zone F. Plugging in numbers properly. Always do not go for integers. Always do not go for positive numbers unless it's stated in the question. That's a very, very important takeaway from this question. Apply zone F. Multiplying by a negative number reverses the inequality. This is a very, very important point that you should remember, especially when you tackle properties of integers questions, which is a very, very, very important topic in arithmetic that's widely tested in GRE. Radhika Pava. Radhika still has a voice problem. You're not able to hear properly. Can you again reconnect, Radhika? Because for everybody else, it's clear, right? The voice is audible, right? Okay, fine. Radhika, I think you need to reconnect. So what have you seen here? What is this beauty of this question? It's the same question, right? Same question, the question type is different. So see how the same question can be asked as a MCQ, it can be asked as a MAQ, or it can be asked as a quantitative comparison question. Interesting, right? So if you just know a few concepts and properties of integers thoroughly, you're sure to attack all these problems with ease, whatever be the question type. Clear? Moving on to the next problem, I'm going to add a little more complexity to this problem. Select one or more answer choices. Again, this is a multiple answer question. If P and Q are distinct odd prime numbers, then which of the following can never be a prime number? Select all that apply. P plus Q, option A. Option B is PQ minus 7. Option C is absolute value of P minus Q plus 1, which means it has to be only positive. Option D is absolute value of P minus Q. Option E is P plus 2Q. Okay, it's a multiple answer question. Though it's select one or more answer choices, it's a multiple answer question. Please do not stop with just one answer choice. Please check through all the answer choices before submitting the answer. Do you get it, Sanket? Radhika, please check all the answer choices. That's a very common mistake that students make. Read the instruction carefully. It says select one or more answer choices. So there is a possibility that there are few more answer choices which are correct. Please check that again before submitting the right answer. A, B, and D. Shreyas. Abhilash says A and D. Prakash says A and D. Radhika says A and B. No. Radhika says A and B. A, B, D, A, C, E. Akash says A and B. Time up. Time up. I think only one or two have got it right. The answers are just A and B. Okay. Let's see how we get it. Ratish says D and E. Why, Ratish? You have seen this problem. You must have seen this problem on a platform too. Yes. Okay, fine. All can apply. Somebody says all can apply. Kivani says A and B. Yes, Kivani, you're right. Absolutely right. Okay, let's see how we tackle this problem. Okay. Let's dip. If you have any doubts, you can always post it on this chat box to remind you. Okay. So A and B are the correct choices here. Let's see how to go about it. Drawing a table like this helps you to tackle this problem. P and Q are given to be distinct odd primes. Which of the following can never be prime? Never be a prime number means they have to be composite number. There should always be a composite number. Each option choice, if you're looking at every option choice, it has to be a composite number. Then that option choice is correct. So when you have the usage of always, the question says which of the following can never be a prime number, right? So in that case, it is advisable to go for an analytical approach. Right? When you have this word never or always, in MCQs and MAQs, it's best to go for an analytical approach. And this can also be solved by something called as ballparking technique or going by elimination. Option A, P plus Q. If you look at option A, it says P plus Q. Can it be prime? Can it never be prime? Let's look at it. P plus Q. P and Q are distinct odd primes. Odd plus odd is even. This is a very important rule that you should know. Odd plus odd is even. If P plus Q were to be a prime number, P plus Q is even. That's what you've got here. If it were to be a prime number, then the only even prime number is the number 2. That's a very, very important point that you should note. The only even prime number is the number 2. Right? P plus Q has to be a prime number, then P plus Q has to be 2. Do you all agree? Because that's the only even prime number that we know of. Now, if P plus Q has to be 2 and P and Q have to be odd, can you think of two distinct odd numbers? Note that P and Q are distinct odd prime numbers. That is what is given there in the question. Distinct odd prime numbers, which means they are always positive integers. So can you think of two odd positive integers which are distinct so that sum is 2? Can you ever think of two odd positive integers which are distinct whose sum is 2? Because 2 is the only even prime number. You can't, right? So that does not exist. Two odd positive integers, two odd prime numbers less than 2 such that the sum P plus Q is equal to 2. I hope you all agree, right? So P plus Q can never be prime number. Any doubts in the first option? Yes, I'm coming to that, Roshan. I'll explain option D. Option B, PQ minus 7. P and Q are odd. Odd times odd is odd. Odd minus odd will always be an even, which means PQ minus 7. If PQ minus 7 is a prime number, assume it's a prime number, PQ minus 7 is even. PQ minus 7 can only be 2 because 2 is the only even prime number that we know of. So which means PQ is equal to 9. Product of two numbers, two positive integers should be 9. So the positive integers can be 1 and 9 or 3 and 3, right? Because 1 times 9 is 9 or 3 times 3 is 9. But look at the question again. The question says P and Q are distinct odd numbers, which means they have to be different. So this is ruled out. It can be only 1 times 9. Again, look at the question. It says it has to be odd prime numbers. 1 is neither prime nor composite. 9 is not a prime number, though there are odd numbers, right? Again, this option is ruled out, which means PQ minus 7 can never be prime number. I hope you got it right. So A and B can never be prime numbers. I've just followed an analytic approach. Simple way of using odd plus odd, odd times odd, odd plus even, odd times even. Only that I've used here. Now moving on to option C. It's odd. Plugging in is the key, I guess. No, Akash, see. Mostly I've used the analytical approach. I have not plugged in any numbers. I've just given you an example here in option C, D, E, but I've just used the analytical approach of odd plus odd is even, odd times odd is odd. Only that is being used here. When the question says never be or always true, it is advisable to go for analytical approach rather than plugging in numbers. Plugging in numbers, you should make sure that you exhaust all the possibilities, which is very difficult. How many numbers can you plug in to exhaust the possibilities, right? So when your question is, it depends on what the question is, what the clause given here is. The clause says always or never be. Please go for an analytical approach like this. Moving on to option C, odd plus odd plus odd, odd minus odd plus odd, or odd plus odd. Sum of 3 odd numbers will always be an odd number. So this can be a prime number. The example here is P is equal to 3 or Q is equal to 7. 3 minus 7 plus 1, I'm sorry, it has to be 5. The answer has to be 5. If P is equal to 3, Q is equal to 7, the answer has to be 5 here. If P is equal to 3, Q is equal to, 5, the answer would be 3, right? Neither case, P plus Q minus 1 can be a prime number. The question is asking never be a prime number, but mod of P minus Q plus 1 can be a prime number. When you say never, it should not be true for any value. Even if it's true for one value, you are not going to pick that option. Hope you are understanding what I'm saying now. Clear? Okay. Option D. Somebody asked for option D. Why is Roshan is asking why is option D incorrect? So P minus Q, odd minus odd is even, right? Oh, option. The question is asking for can never be, but I'm getting it can be a prime number. Can you see that? Roshan, this is a negation question, a question of negation. The question is asking for which of the options can never be a prime number, but D can be a prime number. You get, I'm giving you the values of P as 5, Q as 3. The difference here, modulus is 2, which is an even prime number. So this can be a prime number. You get my point, Roshan? Yes. Now option E, P plus 2Q, odd plus even, which is again odd, can be a prime. I'm giving you an example here. 3 plus 10, which is 13. Do we have to learn this technique? Absolutely, yes, Radhika. This is a very, very important technique. That will be in my next slide. It's there on the platform also. Very, very important technique. Odd plus odd. Very simple rule, right? Odd plus odd. 3 plus 5 is equal to 8. Odd plus odd will always be an even number. Something like that. All those things you have to learn. Yes, Roshan, very good. Good that you've got it clear. So, did you all understand why only options A and B are right here? The question itself is a negation question. The question is asking for which of the following can never be prime. So in that case, only options A and B are true. The other three cannot be the correct options. I hope you got it right. Clear? Okay, fine. Now, somebody, Radhika, was asking for, do we have to learn this properly? That is odd plus odd, those techniques. Yes. Points to remember, a prime number is a positive integer. Exactly two factors, one and the number itself. 2 is the only even prime number. Rest of the prime numbers are all odd. Cannot hear you, ma'am. Kivani, please try to reconnect. I'm not sure what the problem here is. 2 is the only even prime number. Rest of the primes are all odd numbers. This is a very important rule. You all know this. It's just that you seem to be forgetting what it is, right? You see, you do not, I mean, you're not used to applying these concepts properly. These are some techniques that have been taught right from your primary section. Just that it doesn't get registered in your mind unless you learn to apply it properly. Odd plus odd is even, even plus even is even, odd plus even is odd times odd is odd times even is even. It's a very important technique. Yes, Radhika, you have to learn this technique. I'll give you the next problem, which is like an extension of this. So once you learn this technique, though my explanation seems to be a little longer, you can solve it in less than a minute if you know this technique properly. It's going to be very easy. Okay. So at this point, I would like to reiterate that GRE is a skill-based test. So ETS is never going to test you on long calculations. It's going to be very short calculations, or it's very short answers that you will have to know. You should just know to apply the concepts really well. Okay, fine. So I hope you are clear with these concepts, right? So most of the students keep asking about the time duration for the questions. Normally, 0 is considered as a prime. No, Shubham. 0 is not a prime number. Prime number by definition is a number with exactly two factors, one and the number itself. 0 is not a prime number. The least prime number is the number 2. 1 is neither prime nor composite. That's a very important rule that you should understand, because the only factors, what are the factors for 0? How many factors does 0 have? Can you list the factors of 0? 0 times any number is 0, right? Okay. So exactly two factors, nothing less, not more. A prime number is the one which has got exactly two factors. So 0 is not a prime number. 1 is also not a prime number. Okay. So one more question that students seem to be asking is the possible time duration. As I was mentioning, maximum time limit for a question should be 2 minutes. You should not exceed that time limit normally. Okay. If you are thorough with the rules, then bang on. In a minute, you can always eliminate the answer choices. Again, it comes only by constant practice, regular, rigorous practice. Like, for example, Ratish, people who have enrolled on a platform know that we have a comprehensive study plan, a personalized study plan. So we are here to help you out, push you practice on a daily basis. Okay, fine. So there's another long sum waiting for you. And if you do not know the concept, it's a long one, but easy if you have a good concept clarity. If you have internalized this rule of odd plus odd is even, even plus even is even, odd plus even is odd times odd is odd times even. If you have even internalized this concept, the next question is going to be much easier. You will solve it in less than a minute. Shall we move ahead? Yes. I hope it's not becoming overwhelming for you, because it's here. You have to practice at least 1 hour per day for intense problem solving, and then keep increasing the time limit to get that 170. Your goal should be to reach that 170, right? So at least 1 hour every day. If something is odd, then that means it's a prime. No, it's not the other way. As I told you, 9, the number 9 is an odd number. It's not a prime number, right? It's a composite number. All odd numbers are not prime, Radhika, but all prime numbers except the number 2 are odd numbers. 2 is the only even prime number. Did you get it? It's the other way. 2 is the only even prime number. And if at all you encounter any prime number other than 2, that has to be an odd number. But not all odd numbers are prime numbers. Then what is the question of composite numbers here? Moving on to the next problem. Select one or more answer choices. If P, Q, and R are positive integers such that P plus Q plus R is odd, then which of the following statements are always true? Select all that apply. The option A is P square plus Q square plus R square is odd. Option B is Q plus QR plus RP is odd. Option C is P minus Q plus R is odd. Option D is PQR is odd. Option E is PQ plus QR is even. It says, the question says always true. Please be very careful when you say all the options. Ratish, can you all relook at it, please? P plus Q plus R is odd. Then which of the following statements are always true? P square plus Q square plus R square is odd. Q plus QR plus RP is odd. P minus Q plus R is odd. I'm just still waiting for the right answer. What has been going on in the previous sums? As I told you, please understand what I'm trying to say. When the clause is always true or never, please go for an analytical approach. Plugging in does not help at all, because A is equal to B is equal to C is equal to 1 is a specific case. I should say is option E. See, you have not understood the point of the previous problems. That's what I can say. When the clause says always true, Shreyas says D and E. No, Shreyas. Okay. When the clause says always true or never, no, Radhika, A, B, C, and D. No. Go for an analytical approach rather than plugging in. Plugging in numbers will not help for you to solve such problems. When the clause says always true, because you will definitely miss out on plugging in numbers, certain numbers. A specific case, somebody told me A is equal to B is equal to 1. That's a very specific case. It has, when it says always true, it has to hold true for all values. No, all. Okay, fine. The answers are option A, C, and E. Okay, fine. Let's look at what happened here. Why all of you have got it wrong. Option A, P square plus Q square plus R square is odd. We have to check if P square plus Q square plus R square is always odd. So when do you think the sum of three numbers will be odd? Okay, what is the question that says? The question clearly says P plus Q plus R is odd. P plus Q and R are positive integers. P plus Q plus R is odd. That's a question, right? So when do you think the sum of three numbers is odd? Look at this rule. Sum of three numbers is odd when all the three numbers are odd or two of the numbers are even. Only in that case, the sum will be an odd number. Do you all agree? Yes, Ratish. Also in this case, when there is one odd number and two even numbers, the sum will be odd number. Did you miss that rule, Ratish? I think you missed that rule. Do you all agree about this rule? Odd plus odd is equal to odd. Odd plus even is equal to odd. Radhika, do you understand how important it is to know these rules? Yes, Ratish. So you missed the second point. Odd plus even is also odd. Now go back. So I have two cases here. First case is all the three PQR are odd. Case 2 is two of them are even, one of the three values is odd. Right? That's what we just saw now. Now, two of them are even means PQ can be even, R can be odd. QR can be even, P can be odd. PR can be even, Q is odd. Do you all agree? Yes, Shreyas, that's a very common mistake that students make. That is why you need to practice a lot. Practice solving such problems. And please be very careful. Whenever there is an always or never, do not go for plugging in values. It's not going to help you at all. You have to go for an analytical approach like this. So I have two cases. I have sub cases for the second case where I've taken any two of the three terms, that is P, Q, and R can be even, right? Any two can be even. The third one can be odd. Now P square plus Q square plus R square. Now if I get all these to be odd, then my answer is right, because the question says which of the following must be true or always true. So only if It's true for all the cases. Should I need to tick that? Right? Okay. So coming back to this one, P square plus Q square plus R square is odd. So PQR, if all the three are odd, you get odd plus odd plus odd is odd. In case 2, first case, even plus odd is odd. Odd plus even is odd. Even plus odd plus even is odd. So in all these cases, P square plus Q square plus R square is odd. I don't even have to think of plugging in numbers here. Simple rule of addition of odd numbers, addition of even numbers, even plus odd. That's all is required here. That is what I meant by analytical approach. Okay, so I get all these odd. Drawing a table like this helps you to crack these problems easily. So when I get all these odd, I know for sure P square plus Q square plus R square has to be an odd number, right? So this is a correct option. Now Q plus QR plus RP. First case, it is odd, perfectly fine. But second case, A itself, it fails. When P and Q are even and R is odd, you get even, which is an even number. This is not an odd number. So this case fails. So this is not an odd number. You get my point? Again, P plus Q plus R, by the same logic, all these cases, it gives you an odd number. So this has to be an odd number. PQR is odd. Second case itself, it fails. Therefore, this is not an odd number. Now, last option. Last option, it's a very, very common mistake because everything it says, it's about odd numbers. The last one is about even numbers. So please be very careful. This mistake is a common mistake when you do not read the answer choices properly. Get my point? So PQ plus QR is even. So which means it has to be always even. The question is for P plus Q plus R, or can PQ plus QR be always even? Yes, I get all these cases PQ plus QR is even. Therefore, this is also a correct answer. Did you all get it? Did you all get it clear? Am I audible? Is it clear for everybody? Why you have got it wrong? What have you missed? Radhika, is it clear why that rule for odd plus odd, all those rules are very important? Yes? Shall we move on? Wonderful. Ratish, you will not make this mistake because these are all questions on our platform which commonly students make mistakes on. Okay. So when explaining this, we took a lesser time because than the previous sum. The reason here is we know what technique has to be applied. You know that you have to go for an analytical approach, not for plugging in values here. And you know these rules also. This is very important rules. Odd plus odd is odd. This is a very, very important rule. Looks very silly, but I bet most of you would have not internalized this rule. You know this rule. You know 3 plus 5 plus 7. If I give you 3 odd numbers, the sum has to be odd number. Any child knows this. But what is it that you do not know? You do not know to apply it, right? You have not been taught to apply it properly, apply it at the right place. Now, this is the time for you to apply odd. PQ and plus QR will be odd. If P is odd, QR is even, then PQ plus QR will be odd. Let me go back to that. PQ plus QR, when all the three are odd. Okay, case 1, you are giving me a case where P is odd and QR is even. So P is odd, QR is even. Even if one number is even, PQ is even, right? Neelam, you agree? P is odd and QR is even. PQ will always be an even number. QR will always be an even number. Even if one number is even, odd times even will always be an even number. So it has to be just even plus even. You're talking about this case where P is odd and QR is even. You get odd times even plus even times even, which is even plus even, which is even. Understood, Neelam? Wonderful. Okay, fine. So, shall we move on? 1 hour of intense problem solving. I hope it's not overwhelming for you. Okay, fine. Now, we are going to come to the end of nearing the end of this session. I'm just planning to finish it on a lighter note in the sense. I'm not going to crack any joke here, but I'm going to give you simple problems, which you can solve it within a few seconds. Shall we start? Are you comfortable with all these rules now? All 4 sides we have to check. Absolutely yes, Kivani. Absolutely yes. You have to be thorough with these rules. That's very important. It's not by hearting. You know these rules. It's just that you don't know to apply it properly. It's not internalized. Getting it? Okay, fine. Wonderful. Okay. Shall we move on now? Are you ready for the next task? A lighter problem, which I'm going to give you a few seconds to solve. Wonderful. Okay. The next problem here is bang on. I'm just giving you the common mistakes here. I'm sorry. Compare the quantities. X is even, root x is a prime number such that xy is equal to 16. Quantity A is x, quantity B is y. The time starts now. A few seconds, just 30 seconds for you to solve this problem. Or maybe I should give you less than that time. It's a very simple problem, one of the simplest problems asked in GRE. Quantitative comparison question. Just to remind you, there will be just 4 options which are fixed. Option A, quantity A is greater. Option B, quantity B is greater. Option C, both the quantities are equal. Option D, the relationship cannot be determined. Got the right answer? Shall we move on? Yes, most of you have got the right answer. This is a very easy problem. The answer is option C, both the quantities are equal. X is given to be an even integer. Root x is given to be a prime number. That's what is given, right? You're going to compare between x and y. If x is even, please note that square root of x will also be an even number. That's a very important rule that you should know. X is even, root x will also be an even number. So the only even prime number that you know of here is, just given you a long explanation here, but if x is even, root x should also be an even number. Root x is given to be a prime number, right? So the only even prime number that you know of is the number 2. So x has to be 4. If x is 4, you have given this xy is equal to 16. That gives you y also to be 4. The answer is option C. So this is a problem that takes hardly a few seconds for you to solve. Got it? Neelam, did you get it right? Did you get it clear? I'm sorry. Okay, fine. Shall we move on to another easy problem? Yes, guys? Are you all set? Okay, fine. Moving on to the next easy problem. Select one or more answer choices. Yes, I assumed as x is equal to 2. Why did you assume like that? Okay, select, in that case, square root of 2 will be an irrational number. The question says root x is a prime number, right? Prime numbers are not irrational. They're all integers, positive integers. Select one or more answer choices. If y square is equal to 16 and x square y is equal to 36, then which of the following are possible values of x and x plus y? Select all that apply. Again, this is a MAQ, -7, -1, 0, 1, 7. This is also one of the easy problems in GRE. Okay, time up. Okay, only Rati seems to have got the right answer. The answer is option E and D. Let's see how. A and D, Priyanka. Okay. D and E are the correct answers. Okay, let's see what has gone wrong for most of you. Y square is given to be 16. So y has to be plus or minus 4 because 4 square is 16 minus 4. The whole is also 16. So y can be plus 4 or minus 4, right? So when you substitute y is equal to plus 4 here, I get x square is equal to 9. Again, x can be plus 3 or minus 3. So this will give me, when y is equal to plus 4, x is equal to plus 3, I get the answer as x plus y is equal to 7. Y is equal to plus 4 and I do 1. Right? That would be options D and E. Now, when y is equal to minus 4, the second case, I get x square is equal to minus 9. What is it that you have missed out here? X square is equal to minus 9. The square of any real number can never be negative. X square can never be negative. That's never possible in the real number system. The square of a number is always non-negative. Clear? So the answer would be options D and E. Right? Did you all get it? Get the point? Priyanka, am I clear? Wonderful. So we have come to the end of this session. Radhika, did you understand the reason why this odd plus odd? Those rules are very important now for the earlier sums. Thanks, guys. Have a great day.
Thank you for the wonderful session.